This video is for my chemistry students. We're going to be doing some examples in section 9B of your chemistry book. I'm going to skip talking about the what the text says. I'm just going to go right into the examples that they give us, the example problems, and explain things as we go along the way. And in example 911 on page 238, it says if 25 moles of diphosphorus pentoxide reacts with water to form phosphoric acid, how many moles of water are required? Here is the balanced equation. And they've given it to us. Here's the diphosphorus pentoxide, the water, and what do they call that? Phosphoric acid? Yeah, phosphoric acid. There we go. And we learned earlier that these coefficients in front of each of these compounds tells us the number of molecules that are needed to combine, but it also tells us the ratio of moles. For every 1 mole of the diphosphorus pentoxide, I will need 3 moles of water, and I will get 2 moles of the phosphoric acid. Okay? They're always going to be in this ratio. And from this, we can go find answers to other questions they give us. In this first example, they say if you have 25 moles of this diphosphorus pentoxide, how many moles of water will you need? Now, the book uses a unit multiplier. They take the 25 moles of the diphosphorus pentoxide and they multiply it for there's 3 moles of water for every 1 mole of diphosphorus pentoxide. You can do that unit multiplication as they show in the book, or you can just do a simple ratio and do cross multiplication also. I see that they're in a 1 to 3 to 2 ratio. Whatever I have for the diphosphorus pentoxide, I just simply multiply it by 3 to get the amount of water. I'm going to take that 25 and I'm going to multiply it by 3. It will require 75 moles of water to do this. They could have just as easily asked how much of the phosphoric acid is produced. Well, that's easy. How do you get from 1 to 2? You multiply by 2. There is going to be 50 moles of the diphosphorus pentoxide. Now I'm going to pause for a second because some people are confused. How can you take 1 mole of this and 3 moles of that and only get 2 moles of this? I'm not going to get into a lot of explanation, but it is possible. It's what happens. Things combine in a certain way and things get in cracks and everything. You're able to fit things in. Hey, you know what? When I bake a cake, I use 3 cups of flour and 2 cups of sugar, but I still only get 1 cake. All right, so it kind of combines like that. I don't know if that's a good explanation or not. But don't be caught up in the fact that this is 1, this is 3. This does not necessarily have to be 4. In fact, rarely will it be. Okay? Excuse me. Then page 239, the second example, it says, how many moles of phosphoric acid can be formed from 3,550 grams of phosphorus pentoxide? Now, they've given us the value, the amount by mass of the diphosphorus pentoxide. Excuse me. It's 3,550 grams of the P2O5. And I mentioned earlier, in these problems, inevitably, almost always, you have to find out how many moles you have of that substance. Once you get mass into moles, you can then do a mole conversion, a mole ratio conversion, and flip and move on to the next portion. So we have to figure out how many moles of diphosphorus pentoxide this is. Okay, so I've got the 3,550 grams. I'm going to move it over a bit. I'm not going to have enough room of P2O5. Now, the book doesn't show this, but right here I've showed you the mass of 1 mole of diphosphorus pentoxide. P2O5. That means I've got 2 phosphoruses, 5 oxygens. I multiply them out and I add them together. 1 mole of this diphosphorus pentoxide weighs 141.94 grams. I think the book just goes to 1 decimal. They have 141.9. That's 1 mole. Here's my unit multiplier. I'm in grams to begin with at 3,550. So the grams must be on bottom. Those units will cancel. It will tell me the number of moles that I have in 3,550, the number of moles of this P2O5. So I'm going to take my calculator, 3,550, and I'm going to divide by 141.94, and I get 25.01 and on down the line. Basically, I have 25 moles of the P2O5. Well, where have I ever seen that before? In our very first example, they used 25. Okay, it wasn't just randomly that they picked this number. They picked something that's going to show up again. Oh, so if I've got 25 moles of the P2O5, that means I have 75 moles of water and 50 moles of the phosphoric acid. I don't even remember what the question was. What was the question? How many moles of phosphoric acid will you have? Oh, well, there's my answer. If I have 25 moles of this, and they show the unit conversion and everything, and they come up with the 50 moles there. If this had been any number other than 25, let's say it had been 37, well, we would just multiply by 3 to get the amount of oxygen, multiply by 2 to get the amount of the acid, the phosphoric acid. Okay, but it was 25. So, again, convert your mass into moles. It is very important to use units in these problems. I'm going on to page 240, and we're going to attempt this last one. It says a mass-to-mass conversion. It says, what mass of water will react with 3,550 grams of diphosphorus pentoxide? Oh, okay, well, we just figured out that 3,550 grams of diphosphorus pentoxide gives you 25 moles of diphosphorus pentoxide. If you have 25 moles of diphosphorus pentoxide, that means you have 75 moles of water, 50 moles of the phosphoric acid. You try keeping all this straight, but you're trying to say it's like a jungle gym in my mouth. All right, so they want to know the mass of the water. Well, I have 75 moles of water. What does 1 mole weigh? I have the mole on top here. I'm going to put the mole on bottom. I need the mass of water. I didn't figure it out ahead of time. It's going to be 18.016. Is that what it is? Just doing that in my head real quick. And yes, it is. Hey, it's 18.016. I did 1.008 times 2. That gives me 2.016 and plus 16. It's not bad. All right. When you've been at this 20 years, it becomes possible. So the moles will cancel, and we've got 75 times 18. 75 times 18.016 equals 1,351.2. Is that 1,351.2 moles? No. Got to keep your units straight. That is 1,352.1 grams. Notice in the book they have it, it's just 1,350. They probably dropped to significant figures, something we didn't really stress in our earlier lessons, in our earlier chapters. There we go. I hope that helps. Watch for more videos where I will cover the rest of this lesson and how to do the math for it. See ya.